Hi, this is Felix. We are discussing electrostatics from 12th standard physics. In this chapter, today we are going to discuss about the distribution of charges in a conductor. Consider two conducting spheres A and B of radii R1 and R2 respectively, connected to each other by a thin conducting wire as shown in figure. The distance between the spheres is much greater than the radii of either spheres. Suppose if you apply a charge capital Q any one of the spheres, this charge capital Q is redistributed into both the spheres such that the electrostatic potential is same in both the spheres. They are now uniformly charged and attain electrostatic equilibrium. Let Q1 be the charge residing on the surface of surface A and Q2 is the charge residing on the surface of sphere B, such that capital Q which is equal to Q1 plus Q2. The electrostatic potential at the surface of the sphere A is given by V of A which is equal to 1 divided by 4 pi epsilon naught Q1 divided by R1. The electrostatic potential at the surface of the sphere B is given by V of B which is equal to 1 divided by 4 pi epsilon naught Q2 divided by R2. The surface of the conductor is an equipotential. Since the spheres are connected by the conducting wire, the surfaces of both the spheres together form an equipotential surface. This implies that V of A which is equal to V of B. So we have to substitute both V of A and V of B value in this equation and cancel the common value. Then you will get Q1 divided by R1 which is equal to Q2 divided by R2. Let us take the charge density on the surface of A is sigma 1. Charge density on the surface of sphere B is sigma 2 and it implies that Q1 which is equal to 4 pi R1 square sigma 1, Q2 which is equal to 4 pi R2 square sigma 2, and rearranging this finally you will get sigma 1 R1 which is equal to sigma 2 R2. And rearranging this you will get sigma r which is equal to a constant. So when you bring that r to the right hand side you will get sigma which is equal to constant divided by r. When you are removing a constant, sigma is inversely proportional to the radii. Action at points or corona discharge. Let us consider a charged conductor of irregular shape as shown in figure. The ends of the conductor which has large curvature, which means a smaller radius, has a large charge accumulation as shown in figure. As a result, the electric field near this edge is very high and it ionizes the surrounding air. The positive ions are repelled at the sharp edge. The negative ions are attracted towards the sharper edge. This reduces the total charge of the conductor near the sharp edge. This is called action at points or corona discharge. Lightning arrestor or conductor. First of all, we have to see the uses of this device. It protects tall buildings from lightning strikes. What is the principle of this device? Action at points or corona discharge. Next we are going to see the construction. This device consists of a long thick copper rod passing from top of the building to the ground. The upper end of the rod has a sharp spike or a sharp needle as shown in figure. The lower end of the rod is connected to the copper plate which is buried deep into the ground. Next we are going to see the working. When a negatively charged cloud is passing above the building, it induces a positive charge on the spike. Since the induced charge density on thin sharp spike is large, it results in a corona discharge. This positive charge ionizes the surrounding air, which in turn neutralizes the negative charge in the cloud. The negative charge pushed to the spike passes through the copper rod and is safely diverted to the earth. The lightning arrestor does not stop the lightning, rather it diverts the lightning to the ground safely. Next we are going to discuss a very important topic, Van de Graaff generator, and this is also one of the 5-mark question. First we have to see a small introduction of this generator. In the year 1929, Robert Van de Graaff designed a machine which produces a large amount of electrostatic potential difference up to several million volts in the order of 10 power 7 volt. Next we are going to see the principle. The Van de Graaff generator, it works on the principle of electrostatic induction and action at points. Next we have see a construction. A large hollow spherical conductor is fixed on the insulating stand as shown in figure. There are two pulleys we have considered. One is B and another one is C. B is fixed at the center of the hollow sphere and C is fixed at the bottom of the Van de Graaff generator. The two pulleys are connected with the help of a belt made up of insulating materials like silk or rubber run over both pulleys. The pulley C is driven continuously by the electric motor. Two comb-shaped metallic conductors E and D are fixed near the pulleys. The comb D is maintained at a positive potential of 10 power 4 volt by a power supply. The upper comb E is connected to the inner side of the hollow metallic sphere. Next, working. Due to the high electric field near comb D, air between the belt and comb D gets ionized. Positive charges are pushed towards the belt and negative charges are attracted towards the comb D. The positive charges stick the belt and move up. When the positive charges reach the comb E, a large amount of negative and positive charges are induced on either side of comb E due to electrostatic induction. As a result, the positive charges are pushed away from the comb E and they reach the outer surface of the sphere. Since the sphere is a conductor, the positive charges are distributed uniformly on the outer surface of the hollow sphere. At the same time, the negative charges nullify the positive charges in the belt due to corona discharge before it passes over the pulley. When the belt descends, it has almost no net charge. At the bottom, it again gains a large positive charge. The belt goes up and delivers the positive charges to the outer surface of the sphere. This process continues until the outer surface produces the potential difference of the order of 10 power 7 volt, which is the limiting value. We cannot store charges beyond this limit since the extra charge starts leaking to the surroundings due to ionization of air. The leakage of charges can be reduced by enclosing the machine in a gas-filled steel chamber at a very high pressure. Uses of this apparatus: it is used to accelerate positive ions for nuclear disintegration and other applications. Thank you.